I bought a punch card program from 1976. This program is written in COBOL and is designed to be run on a mainframe computer. Compiling this program was done using a COBOL compiler called WATBOL that was designed and developed at the University of Waterloo. The purpose of this program is to audit US tax returns from the year 1976.
So this right here is the full program. There's about, I think, 300 cards here. So I'll start by looking at the first of the program, which is in this set of cards. As you can see here, it says, I think, CLS 555, first 2AB. I think that says works good. And apparently the programming language is COBOL. And it says using the WATBOL compiler. I looked up WATBOL, and I was surprised to learn that that is a COBOL compiler that was somewhat famous back in the day, that was produced at the University of Waterloo, which is actually right down the road from me. And I thought that was interesting because, as you can see on the second card here, it says the Ohio State University. So these punch cards came from Ohio State, but they're using a compiler that was made here in Canada. And of course, the next thing it says here is this program is an income tax return check. One of the first things that stands out is that the shape of the edge of the cards is a little bit different. I have a hunch that that might have been used to tell apart some of the different parts of the program. Maybe there was some kind of a specific convention about the meaning of the rounded ones versus the flat edge ones. So this here is, I think, what they'd call the title card, which looks a bit different from all the other ones. And you can see on this card that there are 80 columns. So the way you can read these cards is actually pretty easy. You can think about each individual card as though it's just basically one line of code. And the actual line of text is written up here at the top usually. You might think it's necessary to try and decode the columns of punched holes here, but in every case, for each column, the actual character is almost always written up here at the top. So here you can see it starts with // and these two columns are identical. And also for the two S's, you can see that those columns are identical. When they first started using this format of punch card, there were apparently only 10 lines. And they were mostly just used for encoding numbers. So in that case, each column would only have a single punch to represent a single digit between 0 and 9. And then of course after that they wanted to represent things like letters and all kinds of symbols. So then they added a couple more lines to the top, and to represent some of the symbols they just punch more than one hole in a single column. So here are the first two lines in our program. And when I saw the double slash, I initially thought that must be for a comment, because that's how it is in C or Java or JavaScript. But I looked that up, and I believe the double slash means that this is a job control language, which makes sense because the first card in the program would be something to actually load it into the system. And here's another statement that looks like it's invoking the WATBOL compiler, which makes sense. Now, I've never actually programmed in COBOL before, but I did a little bit of research in the last couple of days to try and make sense of some of the statements in here. So apparently this was written and debugged January 27th, 1976. So here is an explanation of the program. The purpose of this program, written for CIS 555N, is to do auditing for the IRS by way of verification of all 1976 income tax returns. So from that, it looks like this is probably a computer science assignment from 1976. Another one of those special statements. I don't know what most of these do. Apparently this was meant to run on an IBM 360 computer, and I looked that up, and those were discontinued in the 1970s. So you might be wondering why there's something that looks like SQL statements in here, but these are not SQL, but are instead related to the file control statement, and they're setting up an association between input and output files. So there's a bunch of those. Some of the cards have either blue or pink highlights. I'm not sure if that means anything specific. So these here cards look like comments, and I can tell because the asterisk character is in exactly the 7th column. So that was something else that was very interesting about COBOL programming. The column number where you put something was extremely important. So it says the following files will be used to temporarily store the records in each of the 3 categories. So apparently this is what a blank line looks like in a punch card program. So I believe that FD is another COBOL specific statement. I looked this up, and I think this entire thing here is some complex statement that's related to the FD. I think it stands for file description. And from the name of some of these variables, it looks like the point of this assignment was to try and find evidence of tax evasion. So this here statement, 01 temp-evasion period. I was reading up on COBOL to try and understand these statements, and I learned that COBOL has a very interesting kind of hierarchical method of declaring variables. So you could kind of think of something similar to structures in C. So you have kind of a top level label that you can use to refer to data, and underneath that you have more fine-grained methods to reference the data. And because back in the punch card days everything was line-based, as far as I understand, when you refer to any variable declared with the 01 prefix, that would give you a line that contained all of the members that live under it. So 05 was a number that they would use to declare a data level that was underneath of the 01. So if I'm reading this correctly, this would be something like a structure called temp-evasion that contains these two members. And the name of the two members is filler and rest. PIC is short for picture, if I remember correctly. And pic seems to be a keyword that appears before describing the data type of the variable. And if I remember correctly, X means alphanumeric characters. So if I understand correctly, this would be declaring rest as 132 alphanumeric characters. And I'm assuming filler would be just a single alphanumeric character. And here's another couple comment cards. The following two files are the templates for the 1975 and 1976 tax returns. Note that the variables have the same names. More of these FD statements and more variables. So now it looks like we're getting into actual variable names that reference accounting terms. So from looking at this, I'm starting to think that maybe the standard is comment cards and blank lines all have the pink highlight on them. So this comment says, the next three files are output files. We have one for each of the three categories: valid, invalid, and possible evasion. In the working storage section, we declare all the headers to be used in the program and also the templates for editing output lines as well as any arithmetic variables. Okay, so it looks like the pink highlight does not necessarily mean comment, because these are definitely not comments. Here's a couple more comments. This is a tax table which contains the high and low values for each tax range. Each of the intervals is assigned a percentage, which is the amount of tax that should be paid. By redefining the above table, we can search the whole table in one easy statement instead of interrogating each interval by a conditional statement. Okay, that's it for the first half of the program. Now let's take a look at the second half. So we'll try to go through this one quicker. So this here must have been a note to the operator that was running the program, because after this commentary card it says, note that although this program is late, it has many enhancements and is more complete than the assignment, I hope. The purpose of the program is to read in a tax return and have the program decide the return's validity and return a report on the findings. So this is starting to look more like actual code. That's kind of interesting that the first half of the program was just setting up input and output definitions and formulas. We will read the two files and make a comparison on their social security numbers. In this program, we decide our course of action by comparing SSN 75 and SSN 76. If SSN 75 is greater than SSN 76, we assume we have a new taxpayer because our files are sequential according to the SSN. If SSN 75 equals SSN 76, we decide we have a match and calculate the return, but if the SSN 75 is less than SSN 76, then we think that a return of 1975 has not filed a 1976 return, and there is a possibility of tax evasion. Here we compute the taxable income, search the table for a corresponding tax percentage, and by these values figure out correct responses from the three possibilities. If the amount of tax paid does not match the amount of tax due, then we will print them on an error in reporting file. If the amount of tax matches, we check for evasion. If the taxable income of 1975 was greater than $5,000, and that income of 1976 has decreased by greater than 33% over 1976, then we write them on a possible evasion file. Print all files where the possibility of evasion exists. Write all files for those who paid the wrong amount of tax. Looks like we're getting to the end of the program here. This is a special section for new taxpayers. The only check we need to make is for the wrong amount of tax paid. And here are the last 4 lines of the program. I'm not exactly sure what they're doing, but it looks like they're just defining the 3 outputs that we want. So people who are, I guess, evading their taxes, people with invalid tax returns, and people with valid returns. And here is the last line in the program. And because they start with 2 slashes, I think these are not COBOL, and they're actually job control language.